friends, welcome to the Adventures of Blink. I am of course Blink and you can find me on GitHub right here. Now, if you find this content to be useful or helpful or just plain fun, leave me a like. It lets me know I hit the mark with the content. And if you want more things like this, hit that subscribe button so that you can follow along and you'll be updated whenever I have a new show release. So in today's episode, we're digging into the Gilded rows. The README's a little thin, the setup instructions are a bit brittle, the code itself was a maze of if statements and special cases, but today we're not reaching for the mop to clean up the mess. Today, we're here to map the maze. Because in legacy code, before you change anything, you need to know what the system actually does. And the best way to do that is to write some tests. Let's take a look at our current status, shall we? First of all, the README and docs. They were minimal, but they're accurate. So good points for giving us accurate information, bad points because there's just not enough of it. Setup and install was a little rough. We found a broken test suite, and that's kind of a problem. We were able to fix it quickly, so that's a bonus. But is it really useful if it's only running one little tiny test? We'll look into some of that today. Dependencies weren't really a problem for the app. The Gilded rows ran just fine from its install process, and everything seemed okay there, so we can kind of give points for an easy install. Tests and coverage. We found practically no testing. Yes, technically there is a test suite available. There's a place to put tests, but the one unit test that was in there was broken. We fixed it. It runs, but it doesn't really test anything useful. We also didn't check for the coverage to see how much usefulness we're testing, so that's going to be something we need to look at. And we'll talk a little bit about code coverage as we dig through the process. Code clarity. This is an obvious red light. We had no modularity. It's just one big block of spaghetti code to dig through. There are no comments to tell us what's going on or why things exist. So that's going to be problematic. As we start to clean up the code base, we want to make sure that stuff will exist. Tooling and developer experience. We don't have any tools that are associated with this. It's pretty much just run your Python and run the tests and you should be fine. But there's probably some things we could add in, like a linter, that if we make that part of the process, we have the ability then to clean up the code and make it friendlier to the eye. It's mildly readable in its current form, but it's definitely not being controlled. And then finally, onboarding speed. This is, of course, a red light because we are the new developer and we cannot contribute to this quickly. So we have some work to do before we can even be ready to contribute to the code base. And that's going to be a problem, especially in the real world. When you're dealing with this kind of stuff in enterprise level code, you don't want your team to take a long time to ramp up. You want to be able to bring a person in and they join the team and they can be helpful and productive immediately. So hopefully after today, we're going to see some of these lights change colors. Let's see if we can go on ahead and dig in and get started. Okay, so I've elected to split screen for a little bit here and we can take a look at both the requirements and the code at the same time. So I think the first rule that I want to dig into here is do not alter the item class or item's property. Now, as the item's property is just we'll dig down here and we can see it's just a collection of these. So we're not actually doing anything special with it. If I look back in the code, the way the items is defined is just a variable. So it's a variable to hold a collection. That's not going to change. I don't anticipate ever needing to change anything about that. But I can protect this item class by writing tests that ensure it behaves exactly the same way every time. So let's start with what that looks like. All right, so now you see I've got the split screen thing going on in a slightly different way. I have the tests on the left and I have the actual app on the right. When I'm writing this kind of unit testing, this is usually how I like to work. I like to keep the original code visible to me so that I can see what it is that I'm trying to work on. Obviously, there is a branch of testing methodology called test-driven development, in which case you would not have the actual code, you would only be writing the tests first, and you would have to define how all that works. We don't have that luxury in this world because we have a legacy code base that we're working in, and so we don't get the option of writing the tests before we see the code. In this case, it makes better sense to me to do it this way. So let's start digging in and see what we can do. First thing, we have this test in here already called test foo, which pretty much just validates that the name of foo is foo. There's not much value in doing this. I see that it has an update quality thing that we're going to assert is the name hasn't changed as a result of, but that's not a valuable test. It doesn't give us any information about the safety of our code or anything like that. It's kind of an obscure thing to even test within the concept of the Gilded rows. So my personal proposal is rip it out. Get rid of it. It's not of value for us to keep unuseful tests around. So I'm going to start just defining a test for the item class. And so we're going to do test item, and you know what? That probably needs to be lowercase. And so I'm going to say that I'm testing that the item class doesn't change. All right, so how do you think we might test that the item class doesn't change? Well, the first thing we're going to do is actually just get some test data in place. So we're going to make something called test data, and we're going to instantiate an item. We'll call this a widget, and we'll set the sell in to 10 days, and we'll set the quality to 5. Now that I've built my test data, I'm ready to actually try to use the class. And what I'm going to do to test this, I only have one method to test with, and that's this REPR method. If you're not familiar, REPR is a special method that exists for Python classes. And what it means is this is how you represent the object in this class as a string. Normally, if I were to do something like print test data, I would get a failure, or I would get some gibberish like memory location information that's being passed back, the pointer address or whatever, but nothing that's actually useful to be able to know what data was put in test data. So this REPR method says whenever you try to represent this item object as a string, I'm going to convert it into this format. And so you can see here the format we've chosen is 3 comma delimited strings that are the name, the sell in, and the quality in that order. So our widget here should actually look like this. I'm going to just put the string out here so you can see it. This is what REPR would return. It would do widget, comma 10, comma 5. And it would look just like that. So what we're going to do to be able to test our class is just add an assert to this, and we're going to say that this is equal to testdata.repr. And when we do that, it's going to validate that this is the format that matches this. So if I come down here and do python-m unit test, which you can see in the README for the Gilded rows Python, this is how you do the unit test. I run this and I get an OK. So I'm passing my test. Yay! I've made some progress. Now I have an actual test that validates that my item hasn't changed format in any way, because I hard-coded this part to expect to match what I'm putting in my test data. It's really important that I have this distinction between the two. One thing is going to be mutable. I always want to know that something's up. Like, let's say, for instance, that I change this to a 7, and this should obviously fail. So when I rerun my test, I now get a failure that says, hey, the data in this didn't work. And so it tells me test item class doesn't change. Well, it changed. And so widget 10.7 does not match what came through in the testdata.repr method. And that's my signal. Like if I were to see that, I know that I've now broken that rule. I've broken my rule that says don't change the item class because something made it represent the string in a different order. So I'm going to put this back to match because we want to have a passing test. And then we'll come back here and validate. Yep, everything's okay still. So we're good to go. We've now made our first rule change. Now I'm going to go on ahead and dig up. Now I'm going to go on ahead and I'm going to dig up what the next thing is that we should look into. So the next thing we see, let's go up here to the top and we'll start at the beginning, that at the end of each day, our system should lower both values for every item. So I'm going to come in here and we're going to make a new test. And I'm going to make this a little wider so we have a little more space to look at here because we can sort of see things. We're only using the right side of the screen there as a viewing scenario rather than a working scenario. So I'd rather have a little more real estate here. And I'll also bring the terminal down here a little bit to give us more. So let's write the next test. So in this test, we're going to test that the cell end date decreases. And we're going to use the same test data widget from up there. Or you know what, I'm just going to say, instead of just the one thing, I'm going to say test factors decreased each day. And so the quick, easy test for this is just to say and I think that may actually fail on me because I need to define that within an array. So I'm going to just put an array around that to say my test data is technically an array. You can see it goes into a dot items. And so I know I want to pass in multiple things. And so this array should be what goes into that. So now I've defined TD is my gilded rows scenario. And so I should be able to do td.update quality. And this, I can now assert that the one item in my list dot name equals widget. But I really don't want to do all this in multiple steps. So what I ought to be doing is this. I can do a shortcut and I can say assert that the string representation of this is that. And so now I should, and I actually need to change my numbers. I should be paying closer attention here. So that should be another passing test. So let's drop down here to the terminal and run it. And I got another OK. So I ran 2 tests and I got 2 OK. That's fantastic progress. So now I know that my next rule, or this whole section right here, is now covered because the item now we can verify it has a sell-in value, we can verify it has a quality value, and we can verify that both of those values get lowered each day for each item. Now our next test, once the sell-by date has passed, quality degrades twice as fast. It's a little poetic. But that means that once the sell-by date has become 0, we've reached the sell-by date, from now on the quality is going to go down 2 each day instead of 1. So the way that we would want to test this is def test quality decreases faster after sell-in. And I'll do self there so that now I've defined my test. We're going to pull in this same general structure because this is kind of how this testing works, is you want to pull in the things and keep them sort of uniform. But instead of setting this to 10, we want to set it to 0. And we want to set this to 2. And so now when we update the quality, we should see a -1 and a 0, because now that the sell-by date has passed, then the quality should decrease by 2 every day instead of by 1. So now that we've written that, let's see what happens if we rerun our tests. We have 3 passing tests. We're making good progress here. So the next rule we're going to look at is that the quality of an item can never be negative. So now we need a new test that's quality not negative. Oh, I forgot to put my def in front of that. Okay, so if I now know that quality can never be negative, what I want to do here is set quality to 0, and we're going to need to test with a couple types of items. So I'm going to call this a 0, and then I'm going to do a new item called a 1. And for the 1, I want the quality to be set at 1, but I want the sell-in to be set at 0 already. And the reason I'm doing this is because it's important to start testing the weird edge cases of everything that happens. If I have an item that has reached its sell-by date, quality should be degrading by 2 every day. The problem is I only have a quality of 1 left. So I want to make sure that that doesn't make the quality negative. So I have one that tests if my quality is already at 0, and I have another one that tests if it was at 1, does it, and it needs to go down by 2, does that offset it incorrectly? And let's see now. So between those items, I should know that, let's see what my 0 should look like. So 0 should go 10 to 9 on the sell by, or on the sell in, and the 0 should remain the same there. And then I'm going to do a second assert in here that does items 1, and we'll grab the, okay, and this one should do 1, and because the sell-in goes to 0, or it's at 0, it goes to -1, and the quality should also go to 0. Now, let's test that and see what happens. That test passes. So now I've validated in each case what it is that I want to see. And I know that the quality won't be negative. Aged brie actually increases in quality the older it gets. So I'm going to write a test. All right, I'm going to grab this, and for this part, I'm just going to change the name to aged brie. And we can even just leave the numbers the way they are. And so what we want to see is that aged brie, well, the sell-in goes to 9, but the quality should go to 6 instead. So let's see how that works. Hey, we're passing tests. This is really fun to be able to knock this out so quickly and to see that I'm now setting up all the rules out of that requirements document. And you know, let's take a moment and look at the code that we have here. This is not hard to read if you think about it. We're defining each test method to tell exactly what we expect to be the truth. So test item class doesn't change. We want to know that we didn't change the item class. And so if this test fails, we're going to get an alert that says it failed. We looked at that already. But with each one of these, test that the factors decrease each day. So there they go. Test that the quality decreases faster after the sell-in date reaches 0. And so we set the sell-in date to 0 and we test it. Test that the quality isn't negative. Test that aged brie increases in quality as it ages. So this is really powerful for us because now we know that these conditions will always be kept. Let's see what the next rule is. The quality of an item is never more than 50.
And breakfast cereals and fruit bats and live...
Give a bit, brother.
That passes as well. So our next item is that sulfurous never has to be sold or decreases in quality. I don't quite know what this means. So never has to be sold. It's sell by date. I don't know what it can be set to say that it's, you know, the sell-in number should effectively be infinity for all I can tell. I don't know what the value is actually going to look like. But we also know it never decreases in quality. So what we're going to do is test sulfurous. And I'll leave myself a note in here. Legendary item that never has to be sold and never decreases in quality. So out of the gate, I honestly don't know what this value is going to be. Let's see what happens. I'm just going to put 10 and 5. I mean, we'll just throw some values in it to see, because honestly, this is sort of a fact-finding thing. So what happens? I honestly think this test is going to fail, but the information that it gives us back should help us understand something about it. You know what? I might need to do print test data 0. And that way we can see the output on the screen. This one, interesting. So I don't know what happens then. So let's go look at the code and see how it behaves, because we don't fully understand what it's doing. So, do you see the problem? Here's where our problem comes in. The item name is not just sulfurous, it's sulfurous, hand of Ragnaros. That would have been helpful to know. Oops, wrong button. So I'm going to scoot the code back over here to the side. And now let's see how this behaves. Still get a failure. That's kind of expected. We wanted to see what the values are that we get. So we put in a value of 0, 2, and it remains 0, 2. So I'm going to make a quick suggestion that if I put in 150 and 25, I'm going to get 150 and 25 in the results. So let's go see. Didn't like that. What's wrong with it? We got an assertion error because the numbers didn't work. Why didn't the numbers work? Well, we made it print out because I forgot to change this. Got to copy the name everywhere. All right, there we go. So now we're getting a passing test. And we don't need the print statement in here anymore. There we have it. So we now have a passing test for sulfurous. We know that the value of sulfurous, both sell-in date and quality, will never change. The numbers just remain whatever they are set to when you first instantiate the object. All right, let's head off to our next test. Backstage passes, like aged brie, increase in quality as the sell-in value approaches. So the quality will go up by 2 when there are 10 days or less, and 3 when there are 5 days or less. But then the quality drops to 0 after the concert. So how would we test this? We're going to do a test. All right. And we can see that there's an item name here that we're going to have to grab. So I'm just going to put this name string equals, and I've got to put quotes around it. There we go. That way I don't have to keep typing it over and over and trying to figure out this whole thing. All right, so I'm going to get some test data here, and I think I'm going to pull one of these earlier examples just because they have a little less clutter in there. So test data equals, and we'll just plug in name string right there. And we'll do the same for, ooh, that could get a little dicey. I can do this as an F string. So I'll come right here. This is a handy little thing in Python if you've never used it before, but if you do an F string, you get the ability to drop values in here. So I can do name string like that, and it will inject that string into my current string. All right, so the backstage passes. Let's go read the rules again, because those are a little confusing. They increase in quality as sell-in value approaches. So if I have a quality of 5, and I'm going to set this at 30 days, then I'm going to add another one And we're going to do like we did in the aged brie example, where we have multiple examples, or maybe it wasn't aged brie. It was one of them that we did that on, where we wanted to test multiple flavors in a single test. So there's this one, and the next rule was within 10 days, then the value is going to increase by 2. So we're going to set this guy at 10 days. And then we're going to increase by 3 at 5 days. So we'll want that one to be 5 days. And then drops to 0 after the concert. So in this case, we are going to have 0 days. And we're going to set the value at 50, just so it stands out on the screen when we do this. And then when we update the quality, so the first one is 30 days out, which means it's going to go from a value of 5 to 6. So this will be 6, and this will be 29. And then I'm going to grab that assertion and paste. And let's see, I had 1, 2, 3, 4 items. So I'm going to need 4 assertions. I do 1, 2, 3. Okay, and in this case, let's see, the next one was at 10 days out. So this is going to become a 9. And it was at 5 when we created it, and it's going to go up by 2, so that should now be a 7. This one was at 5 when we created it, so it's going to go to 4, and the 5 should become an 8. And then the last one should become a -1 for the date, and the value should become 0. So let's take a look. It ran. We got it. We've now defined all of the rules for backstage passes. Now there's a note about conjured items. Let's go back and look at our code again and see if conjured is in the text already, or if that's going to be a thing that we add. I don't see any references to that, so I think that's a new feature that we're supposed to add. But that is not a mission for today. Today we are just making sure that we have a test suite around all of the rules that we already know we have to follow. The last thing I would suggest doing before we pass this up is to come back in here and add into documentation. So you'll notice I did this little triple quote thing. I don't know if you're familiar with this in Python. Every module and every method within a module have to have, or are supposed to, by properly formed standards, they're supposed to have what's called a module comment or a method comment, and that's how they're denoted. You put in the triple quote, and then you just write the comment, and it comes right after the definition for whatever. So up here at the top, I would do another one that's like this, and I would say unit tests for the Gilded rows. And you can put in other detail. I'm not going to do a whole lot right now because I don't want to bore you with me writing a bunch of comments. But down here in this space, the rules state that we cannot alter the item class or the items collection in the Gilded rows class.
And breakfast cereals and fruit bats and large...
Give a bit, brother.
And it's just important to make sure that you have those comments in place so that the next person who runs the test suite has that data available to them. All right, now there's one last thing that we haven't really talked about yet that we want to address while we're in here building unit tests, and that's something called test coverage. If you're not familiar with this concept, the idea of test coverage is that we don't know how much of our code actually got executed by the tests we just wrote. We set those rules out there so that we could put borders on the behaviors, but what we want to do is validate that the code is being run. And so we might be missing a case that we didn't address. So in order to do test coverage on a Python app, or specifically one that uses this unit test package to build its testing with, we're going to, I'm over here accidentally making changes. Let me make sure I'm in the right window. We're going to come back here and we're going to do a pip install coverage. And this is a package that we have. Oh, actually it was already in here, so we're good to go. Shouldn't be a problem. Okay, in that case, we're going to change the way we run our unit tests. So instead of python-m unit test, which we know what that looks like, we're going to do coverage run-m unit test. Okay, and this is going to give us a slightly different output. Actually, it's going to give us a coverage file. And so then the next thing we're going to do is run coverage report. And it will tell us that in the process of testing the gilded rows, so test gildedrows.py, that's where we're building all of our stuff right now, we have 48 statements. We're missing one, which means we've created 98% test coverage just by writing this little bit of testing. So this couple pages of unit tests have now fully covered all of the paths through the gilded rows. That's really important information because that lets us know that we've created safety around what's going on. We've implemented according to the rules, we've met the requirements, and we are making sure to actually run the code that we test. Now you can pass this into other types of tooling. One of my favorites is SonarQube as a way to do further analysis on your test coverage package and the way that you're delivering your unit testing. And there's some really valuable things in there as well in terms of static analysis. So they can check some of the code that you've written to see if it has a security hotspot to it, or if it's written in a way that's inefficient or scary or doesn't meet normal maintenance standards. So there's some ways that you can automate your way around that. Today we're not going to dig into those. It's important to know that they exist and they actually function off of this coverage report. So when you build your project and submit it to run through something like SonarQube, they will ask where your coverage file is, and part of what you will do is generate that coverage file and pass it into SonarQube as a way to help scan your project. Keep that in mind as a place that you might go someday. And I think I can actually link a previous example of connecting to something like Sonar. I think we did Sonar in a previous season, so I'll go find that and make sure there's an easy way to get at it from here. So now we've got running tests, and we've gotten some really valuable running tests. We've actually managed 98% coverage in just the little bit of time that we've been working today. This is a fantastic start to what we're doing with the Gilded Rows. Why is this important though? Well, let's think about it. All of these tests were built on the rules that we were given. So if you think back to the way that this would work in a real world scenario instead of a contrived example, somebody's going to come to you as a software engineer and say, hey, I have these requirements that need to be fulfilled in the code that you're maintaining. Please implement this for us. And they've given you a list of things that they want done. This is how we want it to behave. This is the way that it should calculate XYZ. All of those things should be listed in some sort of requirements document. Most places do this fairly reliably, even if maybe not efficiently. There are some scary ways that you can misuse the requirements gathering process. But at the end of the day, we all need some kind of requirements because that's how we know what we need to change. And so the value of what we're doing here is turning those requirements into code. We now know that we meet all of the coding standards that the people put before us in terms of what the code is allowed to do and not do. And so now, whenever we make changes, it's a quick run to make sure that we have, not broken any of the current unit testing. And that's going to be something that we investigate next week. So make sure you tune in. We're going to have some fun as we start the refactoring gambit. I'm looking forward to it, and it's going to be great to see how this Gilded Rose code gets better. So we'll see you next time.